Well, good morning, ladies and gentlemen. Welcome to the second InnovaConnect event brought to you by the VinFuture Foundation. Can I please have a warm round of applause? Can you please clap your hands to commence today's event, please? Thank you. Thank you very much. And for those who don't know what the InnovaConnect series are, the InnovaConnect series is dedicated to fostering discussions, discoveries, and research on crucial topics ranging from environmental problems to issues related to human well-being. And this time, we are very proud to bring this event to one of Vietnam's finest leading institutions in terms of basic science, University of Science, Vietnam National University, Hanoi. And for this reason, we would like to extend a heartfelt appreciation to the Board of Management, to the faculty, to the staff of the university for helping us organize this event and also making this a reality. And distinguished guests, allow me to introduce to you our very esteemed panelists participating in today's event. From University of Science, Vietnam National University, Hanoi, we are pleased to introduce Rector Professor Vũ Hoàng Linh. And representing the VinFuture Foundation, it is our Managing Director, Dr. Lê Thái Hà. And of course, our distinguished speakers for today, Professor Kenneth Leung, Chair Professor of Environmental Toxicology and Chemistry and Dean of School of Energy and Environment at City University of Hong Kong, China. Coming up next is Professor Ming Wong, Advisor and Research Chair Professor, Environmental Science at the Education University of Hong Kong, China. And representing the Vietnamese sci-tech community for today is Associate Professor Binh Minh, Senior Lecturer and Expert in the field of Analytical Chemistry and Environmental Chemistry at the University of Science, Vietnam National University, Hanoi. And to kick off today's event, may I please have a warm round of applause to welcome Rector Professor Vũ Hoàng Linh to deliver the opening remarks.
Distinguished guests, scientists, and students, ladies and gentlemen, good morning. I am very pleased to this scientific event co-organized by our university and VinFuture Foundation. The second InnovaConnect workshop with the topic Impacts of Organic Contaminants on Ecosystem and Human Health. As you know, the VNU University of Science affirms itself as one of the leading universities in Vietnam in basic sciences and technology. And we also have partnership with a large number of academic, social, and industrial institutions worldwide. We are fully aware of the importance of the connection to the world's class research in order to promote our education and research activities and expand our collaboration network and reputation even further. Today, we are honored to welcome two distinguished guests, Professor Kenneth Leung from City University of Hong Kong and Professor Ming Wong from the Education University of Hong Kong, China, who are leading experts in the field of environmental chemistry and ecotoxicology. The scientific topics of these InnovaConnect workshops are related to the environmental pollution and toxic impacts of new and emerging organic chemicals. This is an important emerging issue and has received considerable attention in recent times. We would like also to inform you that recently one of our colleagues, Professor Trần Mạnh Trí, succeeded in receiving Ta Quang Biểu Award in 2024, the highest reputation national award in Vietnam, by a series of papers in this research field. And Professor Trần Mạnh Trí actually is a young member of the research group led by Professor Binh Minh. We would like to express our appreciation and sincere thanks to the VinFuture Foundation for the constant support with various activities to strengthen and promote our education and research mission, and in particular to invite two outstanding experts from Hong Kong for this workshop today. After the workshop, the Memorandum of Understanding between our university and the School of Energy and Environment, City University of Hong Kong, China will be signed. And I hope that we can reach a new level of comprehensive collaboration in the future. We also wish to thank scientists and colleagues from different institutions in environmental science and related fields for joining us at this international workshop. We wish you fruitful discussion and a successful workshop. Thank you.
Professor Vũ Hoàng Linh, thank you very much for your opening remarks. And now please join me in welcoming our representative of the VinFuture Foundation, our Managing Director, Dr. Lê Thái Hà, to share with us a few words.
All right, very good morning to everyone. Dear Professor Dr. Habil Vũ Hoàng Linh, Rector, University of Science, Vietnam National University, Hanoi. Dear Professor Kenneth, Leung, Professor Ming Wong, and Associate Professor Binh Minh, the keynote speaker of today's seminar. Dear fellow scientists, journalists, and students. On behalf of the VinFuture Foundations, I welcome you all to the scientific seminars on impacts of organic contaminants on ecosystem and human health, challenges and solutions. This event is part of the VinFuture Foundation's InnovaConnect series, representing a significant advancement in our mission to foster academic exchange, professional collaborations, and cooperations between the world's leading scientists and top universities and institutions in the field of technology in Vietnam. At this InnovaConnect event, we are honored to have the companionship of the University of Science, Vietnam National University, Hanoi, one of the finest and distinguished institutions in Vietnamese higher education. With an expansive campus of nearly 7,500 students in 97 majors and fields of study, HUS affirms itself as the Vietnam's leading universities in the fields of basic science. Notably, HUS also boasts partnership with 70 recognized academic, social, and industrial entities from 35 countries and territories worldwide, highlighting its global impact and aspiration to expand its network even further. And dear distinguished delegate, with a young, dynamic, and creative workforce, Vietnam strives to rise to a higher position on the global map of science and technology. International cooperation is key to achieving this goal. And one of the essential missions of the VinFuture Foundation is to connect the Vietnamese scientific community with the world, fostering momentum for scientific research and promoting cooperation to develop beneficial technological solutions for humanities. InnovaConnect will provide Vietnamese scientists with the opportunities to exchange experiences, knowledge, and ideas with leading scientists. And this interaction will help the world gain a more comprehensive view of Vietnam as a country dedicated to promoting and prioritizing investment in technology development, thereby gradually affirming the nation's position on the global map of science and technology. And today's scientific seminar will serve as a forum for Vietnamese and international scientists to exchange information on the latest technological advancement in monitoring and managing persistent organic pollutant and emerging chemical of concern. And it will also highlight advanced solutions for sustainable development. Esteemed professor will discuss the current stage of international and Vietnamese collaborative effort for effective pollution management, helping to identify the challenges and opportunities for Vietnam in this field. Today's event holds significant importance in the context of global effort for environmental and climate preservation. Vietnam, with its stable political system, strategic geographical locations, abundant human resources, and rapidly developing research infrastructure, poses the conditions and potential to play a crucial role in the regional and global sustainable development initiative. And in the VinFuture Foundation, believe that today's InnovaConnect event will serve as an effective bridge, enabling Vietnamese scientists to access and engage directly with the world-leading expert in pollutant management. This will contribute to establishing Vietnam as a reliable partner in regional and global environmental effort. Once again, on behalf of the VinFuture Foundation, I sincerely thank the delegates, scientists, researchers, students, graduate students, and journalists for attending the seminar today. I wish everyone good health and wish the seminar great success. Thank you very much.
Dr. Lê Thái Hà, thank you very much for your remarks. And now, as we transition to today's topic, impacts of organic contaminants on ecosystems and human health, challenges and solutions, I would like to invite you all, our audience, to enjoy a brief trailer, a short introduction video that we've prepared to set the stage for our upcoming discussions. Please take a look.
In a world on the brink of an unprecedented environmental crisis, where the very fabric of our delicate ecosystems hangs in the balance, each ripple of pollution threatens the intricate web of life upon which our planet's health and our well-being depend. In this pivotal moment of environmental urgency, where the consequences of our actions reverberate through the interconnected tapestry of life, welcome to the arena where innovative minds converge to tackle the urgent challenges of our era. The VinFuture Foundation proudly presents the second InnovaConnect event, Impacts of Organic Contaminants on Ecosystems and Human Health, Challenges and Solutions. Meet Professor Kenneth Leung, Chair Professor of Environmental Toxicology and Chemistry and Dean of School of Energy and Environment at City University of Hong Kong, China. In 2018, he was selected as one of the top 100 Asian scientists by Asian Scientist magazine. Since 2021, he has been recognized as one of the top 2% most cited scientists in marine biology and hydrobiology in the world by the Stanford Elsevier Indicators. Also featured as the seminar's speaker is Professor Ming Wong, a member of the European Academy of Sciences and Arts, advisor and research chair professor, environmental science, at the Education University of Hong Kong, China. He has published over 850 SCI papers. Professor Wong is ranked 6th for 3 years and 8th for 1 year globally in environmental science, according to the world's top 2% scientists by Stanford University 2020-2023. Representing the Vietnamese sci-tech community is Associate Professor Binh Minh, a senior lecturer and expert in the field of analytical chemistry and environmental chemistry, and is presently affiliated with the Faculty of Chemistry, University of Science, Vietnam National University, Hanoi. Associate Professor Minh has been the author and co-author of more than 150 international publications with more than 7,800 citations. With these exceptional speakers, we are excited to invite you to the second InnovaConnect event. Join us on this journey as we explore the impacts of organic contaminants on ecosystems and human health and uncover the challenges and solutions that lie ahead.
And now it is my pleasure to introduce our first speaker for today's event, Professor Ming Wong, Changjiang Chair Professor of the Ministry of Education in China and Senior Advisor of the State Key Laboratory of Environmental and Biological Analysis, Hong Kong Baptist University. Professor Wong will be presenting his research regarding managing legacy persistent organic pollutants and emerging chemicals, insights from UNEP GEF projects. Can I please have a warm round of applause to welcome Professor Wong?
Thank you very much. So I will be very brief. I will talk for 20 minutes. So my job is to highlight some major issues about POPs, emerging chemicals, and more recently about microplastics and associated chemicals. based on a few projects I have involved the past 20 years. Now, so I'm from the Education University of Hong Kong. I was born and brought up in Hong Kong, spent most of my life in Hong Kong except a few years in England and Canada. Oops. Now, according to the sustainability pillars, environmental sustainability is the most important one. And the Lancet Commission on Pollution and Health indicated pollution is the largest environmental cause of disease and premature death in the world today. So chemical pollution, in fact, is a significant global concern. So this is a map showing the problem I borrowed from the publication. Now, what are POPs? POPs, they are natural or anthropogenic organic pollutants. They are very toxic, persistent. They can be bioaccumulated in living organisms, and they can travel long distance. Surely there will be a lot of adverse effects like causing cancer, reproductive impairment, development, endocrine disruption, and so on. So we need to look at the sources and pathways of these toxic chemicals and then eventually affecting our ecological and human health. So grasshopping effect, I'm sure you know about this. So these chemicals, they will travel long distance, and it would not be very fair for those living in polar regions receiving all these toxic chemicals. Timeline about POP. So I'm sure you all know about Silent Spring, which raised the human health concerns in 1962, and then eventually different parties in different organizations joined hands to look at this issue. The project I have involved, the first project is called Regionally Based Assessment of PTS, Persistent Toxic Substances. So heavy metals, toxic chemicals are included because we have a wider term here, PTS, rather than POPs. And another one, Stockholm Convention, I'm sure you are familiar with. The POPs originally, there were 12 toxic chemicals, they call them dirty dozen. So basically, they are anthropogenic and also environmental pollutants. So basically, the 12 chemicals we were dealing with, most of them are chlorinated hydrocarbon pesticides. And then 2 industrial chemicals, HCB and PCBs, and also 2 unintended byproducts. We don't intend to produce them, but somehow when you burn rubbish, especially burning plastics under relatively low temperature, you will generate dioxin. So we need to deal with all these chemicals. Now, within this project, it's a large-scale project. The world was divided into 12 regions. So I was lucky enough, I was assigned as the coordinator for the 8th region, which is including North and Central part of Asia. So we were having close communication with Japan, Korea, of course, China, Russia, and other countries. So in the end, after 3 years, well, actually it's more than 3 years because I also took part in the preparation of the project. So eventually we have produced 12 regional reports according to the 12 regions. And then eventually I was also involved in compiling the global report. Afterwards, we have also organized quite a number of workshops trying to standardize methodology. I must admit, during that time, 20 years ago, it was very difficult to look at this data generated by different countries, using different sampling methods, analytical methods, and also the way for presentation, so it was difficult. So all these workshops are trying to address these difficulties. And then we also had some trial joint venture. This is one of them about the East Asian trial POPs air monitoring in 2004. I think Vietnam was also involved. Now, this project is my turning point of my academic career. After taking part in this project, we set up a laboratory, we call it Tier 2 laboratory for analyzing POPs. When I was at the Hong Kong Baptist University, I was the director of a Croucher Institute for Science, Environmental Science for over 12 years. So we have been equipped with these equipment, and we were trying to look at the Pearl River Delta, about the POPs, the sources, phase, and environmental and health effects, and also some other study, for example, electronic waste. Because during that time, a lot of electronic waste went to China, and then they tried to salvage all these materials. They're trying to look for precious metals like gold, silver, and platinum, so create a lot of problem. So this is about e-waste. E-waste, it serves as a toxic transformer. So the sites are very toxic, and we had difficulties in analyzing the toxic chemicals. So we did chemical analysis, we did biological assessment, and so on. And then eventually we did a food consumption survey, and then we tried to link up the contaminants we found in food and also the body burdens by looking at human tissues. So obviously, there seemed to be a very significant correlation with the toxic chemicals transferring into the environment, into our food, and then accumulate in our bodies. So these show you different diseases like cancer, respiratory diseases are on the rise. Eventually, another project I took part, also supported by UNEP and Jeff, is to support the sound management of chemicals throughout their life cycle. We concentrate on developing countries and also countries with economy in transition. So we were trying to communicate with different parts of the world, and then eventually we have a ranking about these toxic chemicals. Now, heavy metals ranked number 1, PAH number 2, and then the third one, mixture effects, the chemicals mixing together, and open burning, and so on. I'm sure you can find this publication using the link. So these are the toxic chemicals we were trying to look at. So remember, more than 15 years ago, we were trying to look at all these toxic chemicals. Nowadays, we are still finding solution. And then the third project, I wasn't involved as the principal investigators. I was the reviewer of the final report. So Plastics in the Circular Economy, published in 2018, they were trying to look at the problems, chemical and waste, because POPs are produced during production and disposal of plastics. Also climate change, international waters, these plastics going everywhere, biodiversity was affected, and then eventually land degradation and food system were affected. So I was linked up with a few institutes in mainland China to look at the problems about phthalates, about these plastics used in agriculture in China, also sewage sludge recycling, and also fertilizer. So we found out phthalates, the toxic chemicals derived from plastics, are everywhere. So we also took part in writing some review articles, for example, emission, fate, and transformation of microplastics in biotic and abiotic compartments, the global status. In Hong Kong, at our university, we also have a small group looking at microplastics and other toxic chemicals. So this one is about the microbeads, microfibers we found in the southern part of China, the Pearl River Delta. And what's alarming is the microplastics are found in the fish we eat culture in the area, because mariculture is also important in Hong Kong. So two chemicals associated with plastics, bisphenol A and phthalates. And I'm sure you heard about these toxic chemicals. For example, bisphenol A was found in baby bottles. When you feed your baby, you warm the milk, and then eventually BPA will be released. And then phthalates are also used in a wide variety of products. For example, phthalate was used illegally in Taiwan 15 years ago. They added into drinks. We call it a clouding agent. Now, you're supposed to use more natural products like coconut oil. So obviously, using this is cheaper, more effective, giving out pleasing color, but there would be endocrine disruption effects. And also, phthalates are used in a lot of household products, even cosmetics, lipsticks. So, warning for the male audience: if a girl wearing lipsticks like that try to kiss you, you have to think twice. So this slide summarizes all the all these two toxic chemicals derived from plastics. They are endocrine disruptors affecting our development and also hormone system. You will have early puberty for girls and also retardation of males' sex organs and so on. Now, more recently, people try to look at household dirty dozen. This is a new term because in the household, we tend to use a wide variety of products, pharmaceutical, healthcare products, using phthalates, using formaldehyde, papains, coal tar, dyes, and so on. And also perfume, which contain a lot of toxic chemicals. Triclosan is a very common one. Bacterial resistant genes and other effects. Now, if you look at a recent information, you will find out on the link 11 chemicals or groups of chemicals, emerging evidence indicates a risk. So these chemicals are not so new. They are still there. Arsenic, bisphenol A, cadmium, and so on, lead, and so on. They are still our ecological and human health concerns. Now, one thing people would ask me very often, now you're setting up international convention, are they effective? So this is a slide trying to show you the answer is yes. Now, DDT, PCB, PCDD, PCDF, dioxin, and furans seems to be on the declining trend because of the convention. But PBDE is are rising rapidly. It doubles every 5 years. Oh, now, by the way, this is the toxic chemicals in human milk, used as a biological indicator. A group of Swedish scientists have done such a nice job. So the beauty of the Stockholm Convention, you can keep on adding toxic chemicals if they fulfill all the requirements, toxic, causing cancer, causing biodiversity problem and so on. You can add them into the control list. And luckily, PBDE, flame retardant, was included some years ago. So we need to look at the results some years later. So this is the conclusion. Now, the legacy POPs and emerging chemicals of concern pose grave threats to ecological and human health. The first project informed us about the estimation of sources, concentration, and impacts of PTS on biota and the environment with the international joint venture trying to deal with POPs. Now, the second project on the management also evaluate the potential risk to ecosystem and human health, indicating management strategies would be very important. The third project on plastics and associated chemicals also inform us these chemicals, these emerging chemicals, are still there affecting our human health. Now, the experiences gained from these projects underscore the urgent need for collaborative efforts, knowledge sharing, and capacity building among stakeholders. Now, by implementing substances management practices, we can effectively mitigate the adverse effects of these legacy POPs and emerging chemicals, thereby ensuring a healthier and more sustainable future for all of us. Thank you very much. Thank you.
Professor Ming Wong, thank you very much for your presentation. And now we will be coming to our presentation with Professor Kenneth Leung. Professor Kenneth Leung, we're ready for you.
Thank you. Good morning. Thank you for joining this seminar. So once again, thank you, VinFuture Foundation, for supporting this event, and also the WETA for supporting this event. Just while we are waiting for the slide, I'm going to introduce to you about our university and also my School of Energy and Environment, and briefly introduce about our state key laboratory of marine pollution as well. So CTU, this year is our 30th anniversary. It's a young university, but we are among the top university in the world. We were ranked number 1662 this year by QS, and also we are number 1 in the world in terms of internationalization. 70% of all our teachers are from overseas. In our school, we focus on energy and environment as well as sustainability. We have programs to train engineers, scientists, as well as entrepreneurs. CTU emphasizes translational research. We already create about 800 startups over the past 3.5 years. So in our school, one of the startups now going to become a unicorn. So if you're interested in business for sustainability, our school is a landing site. So in CTU, we emphasize on sustainability, environmental protection, biodiversity conservation. So we are lucky that our research in these areas is really outstanding. Then the China government Ministry of Science and Technology allow us to have this state-key laboratory of marine pollution. So we focus on 3 research areas here, technological development for pollution monitoring and control, as well as eco-safety about the standards for food safety, say the seafood, how much mercury would be allowed in the seafood without harmful effect to us and to the wildlife. And also, final one is about how to clean up and then mitigate and recover the ecosystem. So we have about 65 members in our team. They're coming from 8 different universities in Hong Kong, including Professor Ming Wong. So our lab is well funded. We receive funding like $2.5 million per year. And then we have a very advanced instrumentations for all kinds of research. So let's start the talk today. My topic is quite simple, recent advance in the field, okay? I did a study to learn how to become a senior management in university in Harvard. Then every day I went to the school, I see this slogan. It's very, very nice. Learn to change the world. Then I think as environmental scientists, we always do measurement. Then sometimes we just aim for publication, but that is not good enough. What I'm thinking, we should aim that we measure to improve the environment. This is why we are here. We measure to improve the environment. In this coming 10-15 minutes, I'm going to use some cases to demonstrate how we can measure to improve the environment. 3 years ago, I joined the think tank invited by The Economist, the famous economy journal. At the time, they start a global project called Back to Blue, in which they focus on 3 tasks. One, tackle plastic pollution. Second one, tackle chemical pollution. The third task is to protect and conserve marine biodiversity and fishery resources for our future generations. So in this think tank, we talk about why people only focus on plastic. In fact, we're facing a lot of challenge from the chemical pollutants. So this is the reason why we say a sentence like this in our white paper called the Invisible Wave, Getting to Zero Chemical Pollution in the Ocean. We say that chemical pollution in the ocean should be treated with the same gravity and the same urgency as plastic pollution. Then I tell you the reason why. As you can see in this bar chart there, in total, we are using 350,000 chemicals in our daily life. In the registration system, we have 100 million chemicals being registered. 350,000 used in our daily life. And then among them, at least thousands of them, we call it emerging chemicals of concern. Those we don't have much information about their toxicity, their persistency, and their long-term consequence to us and to wildlife. We have no idea. We call it chemicals of emerging concern. So if you see the donut-shaped bar, the graphic there, it's comparison between 2020 and 2030 in terms of the volume of chemicals in the market. You can see the jump is about 80% between these 2 years. I mean, we're expecting 80% increase by 2030. So not just the number of chemicals, but also the volume of chemicals will increase drastically. So we're facing a big global challenge. So how can we measure for improvement? This is one example. We have been working on all kinds of new pollutants in the Greater Bay areas. So the upper area is Hong Kong. Then we look at the pollutant discharge in the whole area. Then the idea is that if we know how much being discharged, and also we know the effect threshold, how much the environment can take, then we do a risk assessment. If there's existence, then we have to reduce from the source to make sure that the sustainability of our ocean. So, for example, just now Professor Wong just said that PBDE was keep rising by early 2010s, okay, around 2010 to 2015. Many governments stopped using PBDE because they found it in human breast milk, in our tissues, in our brain, and then also it has health effects to us. So PBD being banned at that time, then the industry found a replacement. It is called organophosphate esters. This is called OPEs, okay? Then you can see in this curve, since the ban of PBDE, then you can see the rising of this OPE just exponentially. The increase is like a 5% per year, okay? But although you can find them everywhere in all the products, from textile to furniture, to any plastic wear, but they are not safe, okay? They cause a lot of toxic effects like endocrine disruption, neurotoxicity, affecting our liver, affecting our immune system, as well as affecting the reproduction and growth of wildlife. So we want to know the occurrence and then how to deal with this problem. I just give you one example. In Hong Kong, we measure these chemicals in our rainwater, the storm drainage system, as well as in our wastewater system. What we found in the first figure there, we found the discharge go hand in hand with urbanization based on the coverage by concrete. The area with more concrete, you can predict more OPE in those waterways, okay? Because we don't have any lateral soil, lateral vegetation to absorb them. Then they just bypass, go to the river water and storm drainage, and then go to ocean. And then the second one is we found the concentration much higher during rainy season through the surface runoff. And the pattern of discharge also dependent on the population size in the city. Finally, we look at different types of OPEs, their risk, and then identify the most concerned candidate. We also use a very high-tech technology. The dog already gone, I don't know why. But no worry, you can imagine. We look at, it's called molecular docking. Then we're using simulation to see how this chemical affecting animal cells. And then we can predict what happened and then highlight those chemicals of concern. Now, we expand this study to the whole Greater Bay Area. Then we study this OPE discharge at 8 different river outlets, the estuaries in the region, and also calculate the mass balance based on simulation and hydrological modeling. So, as you can see in the bar chart here, again, we see much higher discharge during rainy season, wet season, and also we find 2 river outlets, Hu Mun and also Hong Qi Ni, the first one and the third one, discharge much higher during the wet season. And then after the mathematical calculation, we find that if we want to keep the ocean safe, then we find exceedance in the Hong Qi Li, one of the estuaries, during the wet season. We have to reduce the discharge in that area at least by 2% of the total mass in the area. So then we inform the government, then we find the source and reduce at the source. Then overall now we are safe for OPE. after doing this analysis and the risk reduction management. Okay, now come to be a more personal study. Everyone has a mobile phone. You are not safe, I'm sorry. Because in the screen, they have put 10 to 20 chemicals. It's called LCM, liquid crystal monomer. If you look at the chemical structure with 2 to 3 benzene ring with different functional group, they are persistent, bioaccumulative, and toxic. Okay? Some of them are suspected carcinogen. Why this thing is important? We discharge 48 million pieces of LCD electronic waste each year. It's a huge amount. And also, we find that it's quite scary now. We find that even though you put a protector on your phone, it won't work because the chemical will go through the protector. Okay? Especially those non-fluorinated ones just go linear, go out from the motherboard into air, into your hand, okay? We also done study in indoor. In an office, if you have more computer, the LCM in the air also higher. Every now and then, try to open the window, get them out with some dilution, or turn up your air conditioner. Try to dilute them from time to time. But we found a good news. In a wastewater treatment system, actually can attenuate, remove 85% of them. Okay, it's quite effective if you use a secondary treatment. However, in the whole world, 80% of countries do not have wastewater treatment plants. Then all this wastewater just go straight into waterway and then into ocean. This is worrying, okay? But if you have money to afford to have a wastewater treatment plant, then we can remove almost 85%. But we still have 15% being discharged into the ocean. This is the reason why in the Greater Bay Area, we found quite a lot of them in our marine sediment. If you see the lighter area, yellow part is Hong Kong, where the sewage treatment plant discharged the water. Okay, so even though after treatment, you still have 15%, because this chemical really persists, they won't be degraded in short time. They accumulate in the sediment. That's why you see high concentration. Their concentration is comparable to other POPs, so causing a concern. Now, we find them ubiquitous everywhere in the ocean, in the sediment. Then, will it affect us? Will it affect the animal in the higher trophic level, like the dolphins? So the answer, unfortunately, yes, it will affect them. We find these chemicals in whole body, even in the brain of the dolphins now. Why now we're using dolphin cell line to look at the detailed toxicology? So the results also quite alarming. What can we do? As a scientist, I said that we should measure for improvement. We have two approaches. First, commercially, we have hundreds of these LCM. We go into screen, go through the toxicology, persistency, and bioaccumulation action. So after that, we will have two lists. A good guy list can keep and use in our mobile phone and computer, television. And then we'll have a list of bad guys. Then we'll kick them out. And they won't have long-term effect to us, okay? So, and then the second one is the technology. We can buy a cover on your phone. Then the cover, we can put some biochar or similar new materials to absorb the LCM to protect you. So this is a solution to the problem. Now, another good news is that we just talked about PPDE restriction. Then before around 2015, in China, we banned many legacy PPDE. So over the year, we have samples from dolphins stranded dolphins for the past 20 years. We have their tissues. Then we can look at the trend. We find that in the top diagram, we see that after the ban, we see improvement, the lowering of the tissue concentration of this legacy PPDE. That means the legislation enforcement will work, that will protect not just the dolphins, but also human. Okay? For those chemicals without legislation enforcement, no change. But luckily, these two groups of chemicals going to ban this year, then we should expect to see decline in the future. Now, more complicated, because Professor Ming asked me to talk a little bit about microplastic. So now we focus on more advanced study on vehicle tire microplastic, because it's very hard to study. They won't fold. They're dark in color. All the conventional detection method won't work for vehicle tire microplastic. But they are number 2 most concerned microplastic in the world. Because if you are driving, every 2 years you have to change your tire, because wear and tear, the rubber actually gone to air, and then after raining, go down to the drain. So we find that in all the time, they add 12 different categories of chemicals to enhance the performance. And then some are antioxidant like PPD. After the transformation, it will become, people will find PPD kill, that will kill fish, but we found hundreds of different kinds of transformation products. Then, right now we have this new technology called long target analysis. We can not just hunting different new chemicals, but also we can use AI to work out the degradation pathway, and also using advanced computational toxicology, we are able to find which one are bad guy, toxic one, persistent one, we should control from the source. Then we will inform the manufacturing, those chemicals shouldn't add to the tire vehicle in the future. This is the way we work as a scientist to advance the science and also enabling sustainable development. Okay, now, finally, I want to talk about, we are not just working alone. We are working on whole world. We want to change the whole world. In this project, we work together with Professor Alice Abosso from York University. We understand that many countries didn't have the instruments, expertise to do measurement of pollutants like pharmaceuticals, medicines. Now, in this project, we developed standard method and sampling kits with YouTube video to teach people how to do the sampling. After they finish sampling, they call the courier service. The courier will send us back the sample for analysis. Then in this study, we cover 258 rivers in the world from over 1,000 sampling sites, involving 127 scientists. Then the result is very alarming, because all the rivers except 2 with medicine. The river doesn't need to take medicine, but because of human, we pollute the river and then causing this problem. Asia, South America, and Africa are the most polluted country in terms of the river pollution with medicines. What we find is very important. We find that most polluted rivers actually in the low to middle income countries in the second region there. If we want to clean up the pollutants, the pharmaceutical products in the world, then we should focus in those countries. The World Bank should help them to build the waste and wastewater treatment infrastructure. And the second thing we find is interesting. If people live longer, they will use more medicines, and then we will have more pollutants in their rivers too. And also this also apply for people, a poor country, because they don't have money to build the infrastructure. Finally, we found the pattern of pollution also differs between social status. socioeconomic status. For poor country, we mainly find painkillers, antibiotics in the river. But for more developed nations, like in Europe, US, or Hong Kong, we find many different kinds of medicine. Especially, we find lots of antidepressants, means people not very happy there. And also, we find lots of heart disease related drugs, as well as diabetic drugs and so forth. This is most important graph in my talk. Among these 1,000 sites, 1/4 of them, 26% of them, have medicines exceeding the safety limit. I give you an example. In the Asian side, see the blue bar. Blue bar means the proportion of the river with exceedance for that particular antibiotics. So in Asia, we look at 13 antibiotics, 8 of them with exceedance. That means we have high chance to generate superbug. They are resistant to all kinds of antibiotics. That will affect us. Then, by prediction, without doing anything, by 2050, each year there will be 10 million people die because of superbugs. So our idea is, now we find those problems, we should stop discharge those antibiotics, and also try to remove the antibiotic-resistant bacteria and the antibiotic-resistant genes in the environment. So, as I said before, we gathered together 127 scientists. We published this work together in a famous journal, PNAS. And then after a year, we got over 500 citations, now even more than 700. Then we got the Best Paper Award by PNAS of the year. So now, we use the same platform to proceed the river study to estuaries, to look at the ocean pollution, and not just pharmaceutical, but all kinds of new pollutants as well. So we hope we will build this global network for monitoring. We will develop new technology like passive samplers for monitoring, and then we will share the data, co-design the solution. Eventually, we hope we can make the ocean cleaner and safer to all. So you are most welcome to join us in this project. So far, we are already covering 55 countries, over 120 scientists collaborating, and also we're covering 160 estuaries. We already received over 100 estuary samples back to our lab for analysis. So we will finish this project by the end of this year. Then we will launch the next phase to look at other pollutants as well. So you are most welcome to join us. If you're interested, please drop me an email. So Professor Ming also asked me to talk about opportunities to publish in some good journals and also serve in some editorial board of the journals. Right now, we have a special issue for marine pollution and ecotoxicology in the 4 flagship journal of Elsevier: Marine Pollution Bulletin, Marine Environmental Research, my journal, Regional Study in Marine Science, and also Journal of Sea Research. Then you can submit paper there, just type in ICMPE, click that section, then I will handle the paper for you. Then I also managing other 2 journals, Fundamental Research and also Water Biology and Security as well. If you're interested to join as an editorial board member or associate editor, please feel free to drop me an email, send me your CV, and your contribution will be most appreciated. So finally, I hope I can convince you that we can measure to improve and change the world. Then by 2025, we wish we can meet this UN Sustainable Development Goal. We shall prevent and significantly reduce marine pollution of all kinds. Once again, thank you, VinFuture, and also Vietnam National University and this faculty of chemistry Thank you so much for inviting me. I hope you enjoy the talk. Thank you.
Professor Kenneth Leung, thank you very much for an amazing presentation. And I do hope that our students were paying very close attention to the opportunities that Professor Kenneth Leung just provided us with. And I hope that you are also keeping up the energy for our very final speaker for today. Let's proceed with our very last speaker, a representative of the Vietnamese sci-tech community, Associate Professor Binh Minh. He will be presenting his research regarding 2-decade research achievements in persistent organic pollutants and endocrine distressing chemicals in Vietnam and perspectives for regional and global collaboration.
Okay, so thank you very much. And first of all, I'd like to express my sincerest thanks to our university and also VinFuture to organize this very timely events. And also I'd like to thanks all of our colleagues to be here, that the people are working with us for quite a long time. And today I would like to just briefly introduce what we have done over the last 20 years. So yesterday I talked with two professors that this is a big challenge for us, that how to summarize the things that we have done for a very long time in about 15 minutes. So in my presentation, I will highlight some of the important things that we have done over the last 2 decades. Okay, so I think Professor Wong already introduced you. This is a glance of our subjects today. So actually, we have here 2 groups of chemical. The first one is on the left side, is a persistent organic pollutant. Those chemicals include the classic chemicals such as pesticide, and some industrial chemicals such as polychlorinated biphenyl and polybrominated diphenyl ether. So they are very persistent and high accumulation and very toxic. And because of the high toxicity, those chemicals have been banned in most of the country. On the right side is endocrine disrupting chemical. So those chemicals is emerging chemical of concern. So we have here the phthalate ester, siloxane, and paraben. So those chemicals are used in large quantity as a plasticizer in plastic product, in textile ink, and especially in the personal care product in the cosmetics. So that means that those chemicals are present in many of our personal care products, such as in your lotion, in the scrub, in the shampoo, and it's actually surrounding in your everyday life. And there's one more chemical we call unintentional produced chemical. So those chemicals that people don't want to produce that, but they are unintentionally released from the different thermal processes and burning of the biomass and fossil fuel. And unfortunately, those chemicals are very toxic. For example, dioxin and polyaromatic hydrocarbon. Those chemicals, especially the dioxin, are known as the most organic toxic chemical. Okay, so this slide summarizes to you the technical assistance project in Vietnam, supported by the Global Environmental Facility in Vietnam. So actually, Vietnam has successfully mobilized more than $16 million for capacity building and environmental remediation by persistent organic pollutant. And those in this slide showing some of the important projects supported by GF. And on the right side, it's some comprehensive research program have been conducted in Asian Pacific region, including Vietnam. So actually, the message from this slide is actually Vietnam has been very active in the region in conducting the research and environmental remediation for the persistent organic pollutant over the last 2 decades. Okay, so this is the story of our research conducted in our groups in collaboration of the international laboratory. So actually, we have 3 periods of time. The first one is from late 1990s to around 2008, when I was at ASIA University. So in ASIA University, we have the ASEAN Pacific Marshall Watch program, and this is a comprehensive monitoring in different environmental media. So myself and Dr. Nguyễn Hùng Minh we are in charge of research in Vietnam, and we published review papers in the review of environmental contamination and toxicology. Okay, so the next period is from 2010 to around 2016, when I returned to Vietnam National University and went up the research groups, and we started to do research on the endocrine disrupting chemical, and also we have published 2 book chapters in order to review the information from this period from the 2010 to 2016. And from the 2016 until now, we look at the investigation on some emerging contaminant in different informal waste recycling area and indoor microenvironment. And we are now preparing the 2 book chapters for reviewing those information. So this is just to inform you that how seriously we are in conducting the constant and comprehensive research on the persistent organic pollutant and endocrine disrupting chemical in Vietnam. Okay, so for now, I will talk about some of the most important findings of our research. So this slide shows you the results of ASEAN Pacific Mass and Watch program. This is showing the concentration for each bar indicates the concentration of the DDT, and which is a pesticide, and also PBD as an industrial chemical in mass and collected from various locations in coastal water in ASEAN Pacific. So you can see here is clearly that for the DDT is high in the agriculture country like Vietnam. And for the industrial chemical such as the PCB and PBD, the level is high for the rapid industrialized country such as Korea, Japan, and China. Okay, so this is another interesting global monitoring program. This is the results of the breast milk monitoring program. So figure in the left side indicates the concentration in the general population. As you can see, the level in Vietnam is generally low as compared to other regions. But if you look at the figure on the right side, the concentration of the PBD in the e-waste recycling side. So we collected the breast milk of the woman who living in the informal e-waste recycling side, and the result here, showing here, is much higher than as other countries, and it's comparable to those in the industrialized country. Okay, so from now, this is the result of our research group in the collaboration with the international laboratory from the period of around 2012 until now. We started, as I said, we started to do research on endocrine disrupting chemical, and we follow the strategy to use the multimedia monitoring. We are collecting 9 types of environmental and industrial samples, with total about more than 2,600 samples. And over the last 10 years, we have published about 62 publications in peer-reviewed international journals, in which about 45% in top 10 journals in environmental science. Okay, so in order to anticipate the hotspot of the pollution, we survey some of the informal waste recycling area in Vietnam. And this is not specific for Vietnam, but this is also very common in other ASEAN developing countries. For example, a figure on the left side, this is the picture from the end-of-life vehicle recycling, which means that the people will recycle and store some of the outdated vehicle, like car or bike. And we also have the rubber melting in some industrial area, and of course e-waste recycling, who the people recycle electrical and electronic waste, and some high traffic urban area and some industrial activity. Okay, so this is the result of the screening of more than 900 organic microcontaminants in passive air and sector dust by the automatic identification and quantification system with the GCMS database. Using these techniques, we were able to screen more than 900 organic microcontaminants. And we can see here some of the trends. For example, the domestic chemicals, such as phthalate or antioxidant, are predominant, and the concentration indicated by the blue bar here is higher than those in other group of chemicals such as industrial chemical and pesticide. Okay, so if you look more closely at some informal recycling areas, we found some new hotspot of pollution. For example, for the PBDE, the level and the hotspot are present in the urban and in the rubber recycling area. While for the PAH, we found the higher level in the rubber recycling and the end-of-life vehicle processing. Okay, so based on the principal and component analysis, we also can find some association between the chemical concentration of the contaminant and the socio-demographic parameter. For example, the high chlorinated PCB were associated with the consumption of repeat-rich food, and while the lower chlorinated biphenyl and brominated flame retardant were related to the recycling activity. Okay, so now I will talk about the new emerging of concern, the endocrine disrupting chemical in dust. We are using the dust as a very simple but very useful indicator for monitoring of the toxic contaminant. So again, this slide shows, as mentioned by Professor Wong earlier, the level of phthalate and siloxane, which has been used largely in the cosmetics and plasticizer in plastic products, showing the higher level than those other chemicals. Okay, so this is another interesting result. If you look at the phthalate and siloxane in indoor air from the different microenvironment in Hanoi, in Vietnam, we found that the high level of this chemical in the hair salon and in our home than other microenvironment, indicating that those environments are source of this chemical and highlight the risk for the exposure and the role of the indoor environment for the human exposure to those chemicals. Okay, so in order to further highlight the importance of the indoor environment, we also check the concentration of the phthalate and siloxane in indoor and outdoor air collected at the same location. And it is clearly shown here, the concentration in indoor air is at least 3 or 8 times higher than those in outdoor air at the same location. Okay, so how the environmental level can have the impact on the human exposure. So based on the residue concentration in the indoor air and the dust, we able to estimate the daily intake dose of the chemical based on the two exposure pathway. It's air inhalation and dust exposure. So this slide summary of our research, and here we have some important findings. For example, the children in urban and the end-of-life site receive the higher daily intake dose of organic contaminant. And the exposure pathway contribution can be vary between compound and the exposure groups. This is again the same thing, but for the endocrine disrupting chemical. So we found here it's air inhalation is dominant pathway for siloxane, and water intake is dominant for the phthalate compound. And dust is not a significant exposure pathway, which is different from the previous slide for the persistent organic pollutant. Okay, so I will move to the issues of the environmental remediation of the contaminated hotspot and reduction of the unintentional produced persistent organic pollutant. As I have mentioned earlier, so Vietnam has successfully mobilized more than $16 million for the capacity building and remediation of the environmental contaminated hotspot. So this slide summarizes the effort of Vietnam during the last, I would say, more than 20 years to treat the soil contaminated by dioxin from Agent Orange. So, for example, in Da Nang's area, the USAID provide more than $100 million to clean up the soil contaminated dioxin. So that's why you can see after this one, you can see the Da Nang have the very nice the airport as it is nowadays. Using the in-pipe thermal desorption technology, more than 19,000 cubic meters of the contaminated soil and sediment were treated. So similarly, in the Bien Hoa area now, the first phase of the project has has been started, and it is planned that more than 100,000 cubic meter of the soil will be treated. Okay, so this is the result of the UNIDO project in which Professor Wong already participated in this project. So I highlight it again, that how we can reduce the unintentional chemicals. So we cannot eliminate all this, but we can only mitigate the emission. So this is an example of the demonstration of the best available technique for the reduction of dioxin from waste incineration. So by applying some of the possible best technique measures, such as appropriate sorting of the material and strict control of the temperature and the better control of the improve of the gas treatment system, we can reduce the emission of the dioxin. Okay, so far, as I have mentioned that based on our research, that all of the research here is based on the strategy that using the multimedia monitoring program. So I would like to highlight here some of the important monitoring using the air passive example, and also we have the estuary. For the estuary program, like water and sediment collected and analyzed following the same protocol and ensure the high consistent result, as Professor Kenneth has mentioned. And of course, we have some other important monitoring program. So all of these programs will have the common strategy. It's a similar sampling and analysis protocol and relatively quick, simple, and easy to deploy. So those priorities should be considered in future research. Okay, so finally, we would like to express our acknowledgement of all of our colleagues in the national and international network here, listing here. I don't have enough time to mention, but I would like to thank them all for your collaboration over the last 20 years. So everything looks quite serious now, so I would like to show some of our timeline, but this is our interaction over the years. So as you can see here, back very long time ago in 2011. So we have the UNIDO MATPET project, and we have Professor Wong to deliver a keynote speech at this workshop in Anang City. And after a few years, we went together in June 2014, which is exactly 10 years ago in the City University of Hong Kong. And just last year, in the February 2020, we welcome again Professor Wong, even a very short time in Hanoi. And just yesterday, we met at the Lotte, and we are now reunion. And we don't have so much Professor Leung in this picture, but I hope this is only the starting point for our promising research in future. Thank you very much.
Well, thank you very much to Associate Professor Binh Minh for your very enthusiastic presentation. And I'm pretty sure that we are ready to take this event to the next level. And by that, I mean the Q&A segment. And now let's transition to this very eagerly awaited session for today. And for our online audience who are watching this online via Zoom, can you just please kindly send in your questions in the chat box, and we will assign them to an appropriate speaker. And for our audience here present in this room today, can you just please raise your hand, and we'll be glad to move you to a microphone, and that you will be able to exchange and interact with our speakers in a more direct approach. And now can we please get ready for the Q&A?
So thank you very much for all the three speakers for the nice lecture. And I got really almost comprehensive picture from all the legacy and the emerging contaminant. According to Stockholm Convention and the extended, that is fine. Now, I heard that you talk about the list of the legacy and also the list of the emerging contaminant and the trend of the changing. And it's very clear for the legacy persistent organic contaminant, we have a decreasing. That is very clear. Through different kind of the program like Marshall Watch program and recently also in microplastic. On the other side, you show also the other trend of the emerging contaminant, like the brominated flame layer tactan, PBDE, and also the other PCB, pharmaceutical and personal care product like paraben, antibiotics, etc. And I'm sure a lot of people sitting here in the first row, I need to know you. They are the people, they are expert in dealing with the contaminant, especially Prof, since about 20 years. So Professor Tuan, Dr. Binh, and I see the Professor Vũ Đức Nam, many of the people I know since many years, they deal with this program and they are interested. But my first question is, we feeling that you something missed to talk about two very important groups of the emerging contaminants. The first one is about the perfluorinated hydrocarbon. The PFAS now become a very hot issue, especially in the Western country, in Europe. They even now pay a lot of attention for how to analyze and to keep the level in drinking water. Could you please tell a little bit about that? The second one is about the chlorparaffin. This is a group of the persistent organic pollutant, new one. They have been used for the long time, for 10 years, replacing the PCB, but now this also slowly banned and putting as addition in to the index of the annex of the Stockholm Convention. And could you please also tell about that a little bit for the audience? That is my first question, and maybe one by one. And I have the second question later on. Thank you.
Maybe I will respond in general first. Now, well, human beings are very clever. We have been inventing a lot of chemicals. We use them for a while and we found out they are not so safe. That's why we call them emerging chemicals. Now, the most important thing is we are trying to replace these toxic chemicals with other chemicals. We don't even know how toxic they will be. So that would be the problem. Now, in terms of PFAS, I think very concerned in certain countries, as you pointed out, like Australia. So the Clean Up Conference, once every 2 years, there's a special section devoted for PFAS, I think. I will pass on the mic to the real expert here.
So our laboratory has been one of the major centers in the world looking at PFAS pollution. Recent revision of drinking water standards in US causing a big debate because those new standard is closer to the detection limit. And then in many countries, the drinking water may already exceed this criteria, that causing a question whether this is appropriate. But I want to raise another concern. There are over 4,000 different types of PFAS in the world. Many of them are legacy ones. That means they have a long carbon chain. In the old day, they developed these PFAS with 8 carbon, okay? Then since we realized their problem, the industry tried to cut it down. 6 and then plus 2 carbon. And then now we have many products 4 carbon. But unluckily, shorten the chain doesn't mean they are safe. We found several new PFAS actually more potent, more toxic, can be biomagnified in the food web as well. But for those new emerging PFAS, we don't have any standards because we don't have enough toxicological information to develop appropriate standard guidance. So this is what we should work together. We will see ultimately the PFOS, PFOA will decline, okay? With this banding of use, no more production, we're going to see them decline. But in our dolphin sample, we actually see the emerging one climbing up, also apply to our drinking water. This is something we should concern. We shouldn't look back. PFOS, PFOA, they are history. We should look at the new one coming out in now we have to tackle. So thank you.
Well, I think it was not enough information since I think the PFAS became, I think, since about 10 years, an issue. It has been added in the annex of the Stockholm Convention, you know very well. And according to the standard, and especially the US EPA, we have to analyze, I think, more than 10 different kinds of the isomer of those, from C4 to C12. Now it's quite popular and familiar with the people. The problem is now, in Europe especially, that the people dealing with the analysis of this in drinking water is even more difficult. In wastewater, it's no problem. But in drinking water, I think it's still a lacking of the methodology and the other knowledge to solve the problem. And I just visited very recently the conference in Munich, I think about in last April, and a lot of people, and even now, there's still discussion about the development of the new method for drinking water PFAS. And for this, they call a special name, it's a forever chemical. So I hope that you continue to put this in your program. If you invite us to join your program, don't forget to put that in this. I think it's on. The second question is, now for me today, I learned something from you that this, everybody has one. Can be also considered as one sources of polluting and emitting of the liquid crystal monomer. Of course, first they need to be built in liquid crystal polymer, but under the sunlight and other conditions, they can degrade it in monomer. That is, I fully agree, and I learned something new. But from my understanding, this kind of liquid crystal display is covered by another layer, that is ITO, indium tin oxide. I think maybe people from the physics and micro semiconductor technology, they know very well. And over that, the people, most of them, they very carefully cover the one more layer to protect it, the slide. My question is, how far we can help to protect the people suffering and exposure from the liquid crystal monomer?
I didn't explain clearly. The work we done, we already showed that from the motherboard to the LCM layer to the protector, actually we can see the leakage all the way. Even if you put a plastic protector or the glass protector, they still can infiltrate to go out. If you have thicker one, they will go out from the edge, not through the screen itself. Our mitigation is that you can buy a cover specially made. We can have a coating or something like biochar activated charcoal. It can absorb the LCM. That will reduce the release into air and then also protect yourself. This is a simple way. We offer this immediate solution, but in the long run, we only keep the good one and kick out the bad one. But why this chemical come out so easily? Because when they add to the LCD system, they let it freely flow to increase the brightness and the color and so forth. Intentionally, not forming any bonding, just being freely floating in the LCM layer. That's why they're quite easy to release. But in the future, can we modify the structure? Is another consideration for green chemistry by the industry. Thank you.
Thank you very much, Professor Kenneth, Leung, and I believe that that was our First and also the final very question for today. Unfortunately, due to time constraints, I may have to put this to an end. However, before officially wrapping up today's event, we would also like to share an equally important message announcement from outside the VinFuture Foundation is that the VinFuture Foundation is now calling for nominations for the 2025 VinFuture Prize, VinFuture Grand Prize, and the 3 special prizes. The nomination portal will be opened for the 2025 season until April 17th, 2025. And we hope to see you joining us in making a positive impact on humanity by nominating deserving technological innovations that have improved people's lives. And for now, we extend our very heartfelt gratitude to our esteemed speakers, Professor Ming Wong, Professor Kenneth Leung, and Associate Professor Binh Minh for their enlightening contributions. And a special acknowledgement goes out to University of Science, Vietnam National University of Hanoi for their inspiring support. And to our online audience who are watching this via Zoom right now, your participation has been very invaluable, and we are very honored to have had you joining us in this special occasion. The seminar is now coming to an end. However, to our audience who are sitting here right now, we kindly request that you remain seated as we transition to the next segment of today's event that we are about to witness, the signing of Memorandum of Understanding, or maybe also understood as the MOU between the University of Science and the City University of Hong Kong. And thank you very much for your attention during this significant moment.